Cool. 818 race car. Hard. Your car starts at position 0 and speed +1 on an infinite number line. Your car can go into negative positions. The car drives automatically according to sequence of instructions A and R. When you get in instruction A, your car does the following. Position, yeah, you gain some speed, and then your speed left shifts by 1. When you get an instruction R, your car does the following. Your speed is, if your speed is positive, then it's okay. So you just change signs and also stop. Well, not stop, but your speed goes to just one. So okay. So do we move if we don't accelerate? Do we have to accelerate? I guess so. For example, after AR, you go so. So there's not like just stay and just cruise. Now for some target position, say the length of the shortest sequence of instruction to get there. Okay. And the target is between 1 and 10,000. Okay. Feels very breath surgery, but because yeah, I mean, why wouldn't I do breath search? Maybe it considers too many candidates. And you could actually probably pre-process all of 10,000 in the same one if you really try to be fancy. Say about 5%. Yeah, I think I'm just going to do the breath search. And the only two states are precision and speed. So shouldn't that hard to do a breath search? Maybe. No, I'm gonna try it out and see. Yeah. Okay. Yeah. By definition, the length will be the shortest because you only hit that node once, and I think your nodes are precision and speed, and you want to get precision where the precision you go to target, right? So okay. And you start with you start precision 0 and speed of 1. Okay. I'm doing C++ syntax for a second. That's fine. I could actually just use a key. Is that a thing? Or am I just like mixing languages too much a little bit? Alright, let's just see. I'm also just googling this real quick, but don't mind me, there's no pop and what is it? Oh yeah, I think you just pop and then the index, right? Okay, fine. I wonder if this is n square. What's the performance of this? Let me Google this up real quick. I could just do Q. Oh, very pop the font is. Okay. Maybe I should use deck. Okay. How do I use collections.q? Or deck.q. Or maybe I just have to say collections. Sorry, I'm not familiar with how Leetcode does some of these libraries stuff. So, okay. I'm going to pop that. Group and return. Okay, cool. Work right now. Okay. And now, if I should use what's it, name tuples. I think people always tell me to use it, and I agree. I need to practice. Okay, fine. Okay. Return. Oh, it's a length. I didn't return. I do not keep track of this. Okay. Okay. Otherwise, we queue up. What do we queue up? Or pen. I would say push. Okay. I pen. So you Q and A, then the position just adds speed. So you have plus cones of 1, cones of 1, cones of 2 plus 1. Yeah, this would really be more clear if I have a thing, but speed, yeah, okay, and speed is the reverse. We keep some different things. Step it in, and then either 1 or -1, right? So, okay. I think maybe this benefits a little bit from pruning some of the search space, but just so that it doesn't get too slow. But we can also try to test a lot of these manually and see what the performance is. So that's what I'm gonna do. See what at least the answer is. Oh wow. Okay, I mean that's good to know. So we definitely just need some pruning. Does it make sense to go to the negatives? I don't know. Okay. Maybe. Oh, do we? Oh, I do not. I guess I should have kept some state. I forgot about states. It's just like a scene array. This is not in scene, then we need to do it here. I just want to make sure my syntax is right. Oh. Yeah, I think I just said the English stuff and then type that. Hmm. Oh. Wait, did I? No, I didn't. Sorry, I wanted to reset. That's why. Oh, yeah, okay. I guess we're still timing out, which is not unexpected. But nope. Copy, copy and paste that. Yeah, this is kind of ugly though. That's why maybe I should use the name tuples. Okay, that finished pretty quickly, actually. This trying to think what is like a good number to test. 10,000. So it was 2 to the 12, no, 13 is 8,000. So let's try 9,000, like in between two powers of twos or something like that. That's what I want to try. Yeah, okay, one time seems okay. Let's YOLO this. My output is really wrong, so I actually don't know why I submitted this. The, yeah, I was not paying attention. I just want to get rid of the time limited, but it's because I do not accelerate. This does not go. Yeah. So of course it takes that long. Oh well, now it's much slower, but at least it is still well. I have to pay attention more, but I mean, seems like this should be right, or at least like should not give you a longer answer, but this might seem the way as well. But this may be a little too slow, so I'm gonna have to figure out. But let's see, make sure uh, let's make sure it's at least right for, and we can do some optimization. Ah, so even this as well. Let me place my thing somewhere. Okay. Something obvious. The flat research should be right, even if it's not efficient enough. And so, I'm just a little surprised that it is wrong, or that it takes so long, because there should be like, maybe I'm doing too much, but like I imagine there's only like about 40,000 states times the number of speed, and speed is like 10, so like maybe 500,000 states, maybe something like that. But let's see. It's like, don't know why it takes that long, and also it's wrong. That kind of rhymes like a crappy Dr. Seuss thing. But yeah, 500,000. So, ow. Why does it take that long to 500,000 states? Maybe the queue takes. Maybe this thing. Maybe I could clean up. I don't have to use a deck. But why is it wrong? Maybe I have another typo. All right, let's see if we can optimize this first real quick. Let's just say we don't care about memory for now. Is that much faster? Yeah, slightly faster. Probably the set is still doing a thing. But why is this wrong though? Oh, huh. I have the signs on this incorrect. Okay, that's fine. That means it'll take short. Oh, what the? Oh, it's good that I did not fix the cache, so it's probably doing a lot of weird stuff. I'll rush this a little bit. Okay, so good thing is that it works. Bad thing is that it's really slow. Okay. I mean, at least my intuition is correct. I think one thing here is speed. If speed is greater than 20,000, maybe we don't need to do this part for sure. Maybe I could, let's see if that helps enough. Because we definitely still branch out. An absolute anyway. Oh, and it's not called speed because I. Like a second faster. Okay. Can we move to precision as well? Yeah, I guess we might as well do that check for precision as well. Oh, we could have just not cured, but that's another. Yeah, so that's only slightly faster, but is it right? Let's take a look. Okay. I mean, it's a little bit on the slow side. We'll see how the we'll see how the things. We'll see if it's fast enough. I might have to do a few more optimization. Okay, that's fast enough. It's a little on the slow side, but I don't use any memory, so maybe if I used more memory, then it'll be okay. But also, some, I guess people really have huge lookup tables because, or they pre-calculate. And I guess I mean this is also like similar to dynamic programming, right? So you could look at these as states, and then just do the search that way. Um, but and maybe when search backwards, nah, backwards is tough. But I guess they have more crazier lookup tables because I'm using 180 megs or 175 megs and it's still less than 100% of it. Whereas the result of my stuff is slower. So yeah, okay. Um, Okay. Yeah. I mean, I think breadth search is fundamental. So at least the way I did it, I think you would totally expect to give this on an interview in some way. Maybe not this exact problem, but like some structure that is similar to this. I could definitely have as a postmortem or retro. Yeah, I could definitely clean this up. As I mentioned, I would definitely use name tuples so that all these sub all these array indices are easier to read and so forth. But overall, this is just like a queue and like a buffer search. So the code is relatively standard for uh, for that purpose. But yeah, the difficulty is standard-ish. I mean, I think it's a little bit on the hard side due to the optimization, even though that's fun to kind of talk about in an interview possibly. But I think definitely the core of this is standard. I don't know if there's a maybe there's a harder intended solution that they want, but at least the way I did it, I think it's relatively straightforward. I think one thing to note is also that if you store stuff like we have a dynamic programming thing, then then speed always doubles, so you could actually just keep the power of two that you're in versus doubling every time, which in theory, depending on what you're doing, uh, or how you're storing the table, it could be easier. But that's my only observation on that. Um, I'm okay, I think, and I could definitely see this or something similar on a interview. Reference search comes in handy a lot. Yeah, cool.